If topics like levels and histograms sound like black magic, then this is the video for you. We're going to talk about RGB color from the ground up, starting with individual pixels and going all the way to full-blown images. When this video is done, you'll know how to read levels, you'll know what channels mean, you'll know why RGB colors always go to 0 to 255, among many other things. So let's learn digital color from scratch. What's up guys, it's Trent, and recently I've been working on my video for all the blend modes and adjustment layers. If you want to be notified when that comes out, be sure to subscribe to my channel. It'll be posted here in a few weeks. But as I was creating those videos, I realized there's some kind of fundamental basic information that I kept repeating to myself. And I thought, why don't I just pull that all out and make a video for it? And the result is this video here, which is basically a crash course in digital color, specifically RGB colors. So we're going to start with the basics and we're going to build it up level by level. And as always, if you have any questions, feel free to leave a comment below. So let's get started. So let's start with a little bit of physics and engineering background. When we look at a digital screen, what we're really looking at is a grid of pixels. And pixels can have three values in them. They can have a red, green, and blue value. And we can look at these pictures here. These are very zoomed in examples of screens. But you can see is there's always this pattern of red, green, and blue. And we can look at some other examples here. TVs used to look like this. PC, cathode ray tubes, displays. Back in the old days, if you looked really closely at a screen, you could actually individually see these colors. But now the pixel density is so high that it's really actually hard. But this is still what it's ultimately made of. And the reason this works is because of what we call additive color. Now there's two color systems, additive color and subtractive color. So let's take a look at that. Now you've probably heard that when you add all the colors, you get white. However, in our experience, sometimes this isn't the case. For example, if you mix a bunch of melted crayons together, like red, green, and blue crayons, you don't get white, you get some type of brown mush. So what's going on? Well, it depends on how the light is behaving. So here I have an example, and when we talk about additive color, what we're talking about is actual light energy that is being added together. So when we actually have a real red, green, and blue light emitters, those lights will add to give us the white color. Now in subtractive color, something a little bit different is happening. And what we have to understand is that why are certain objects the color they are? So let's consider a red crayon. So a red crayon is red for a different reason than a stoplight is red. A stoplight's red because it's emitting red light. A red crayon, on the other hand, is only red because white light is hitting it and it's absorbing every single color that isn't red and it's reflecting the red back out at us. And that's the reason why a lot of objects are red. Apples, paint on your house, book covers. They are the color they are because they're absorbing everything and reflecting only one color back out at us. Down below here we have this paint example. So the more paint you add, the more colors you're observing and you get a darker result. Usually in real life you don't get pure black. It's kind of physically impossible, I think, but you get a darker color. Now on our computer screen we're dealing with an additive system. So as we add more reds and greens and blues together, we're going to get closer to white. So we don't have to worry too much about subtractive color right now. In this video, we're mostly just going to focus on RGB from an additive perspective. Here I have the three colors in their purest digital form, red, green, and blue. I can show you that by selecting them, and I'm using Affinity Designer. The program doesn't really matter. This color chooser here, this is showing me what color I have selected. So you can see red is fully maxed out at 255. This is the highest value you can have for a color. I'll talk about why in a second, but there's 0 green, 0 blue in this square here. This is just for this one square here. If I go to the green square, you can see now green is maxed out. There's no red, maxed out green, 0 blue. And if I go to my blue one, of course, it's maxed out on blue. Now what I can also do is we can make this less than 255, so I can make it darker. And you can see there's still no red or green, but there's darker shades of blue. If I go all the way to 0, it's black. So this isn't a shade of blue anymore, this is just pure black. The same is true for all of them. If I have the green, if I dial this down to 0, it's at pure black. It goes to red just because that's the default color it does when it doesn't know what to do, but it's black. What I can also do is mix levels of the color. So I can have red at 255. Let's say green is 120 and blue is 200. So we get this kind of shade of pink almost, and that's maxed red, green of 120, blue 200. I can also drag my hues around here. And I can even go around and change the saturation and lightness values. So you can see no matter what color I do, there's going to be some RGB values here. Now, there are some special numbers. For example, if everything is 255, you can see what color we get. And the answer is we don't get any color. We get white. So when all these are maxed out, we get white. And that goes with what we said in the previous section. This is additive color. So we're maxing out all our colors together to get white. Now, something else you should also know is that what happens when these colors are all the same? Well, let's see. 120, 120, 120. Okay, we get this kind of gray. Let's try another one. 200, 200, 200. Looks like another shade of gray. And in fact, this is exactly what happens. When red, green, and blue are all the same, you have some shade of gray. So I'll drag up on the left side. Notice this square here. I'm anchored to the left side, so there's no bias of any color. These red, green, blue values are all the same. So of course, when they're all the same, maxed out at 255 is white. When they're all at 0, it's black. And when they're anything the same in between, it's going to be gray. Another way of thinking about color is hue, saturation, and lightness. And you can see that's what these values are here, HSL. Now, the pixels themselves don't have an inherent HSL value. It's all just derived from RGB. So a pixel has an RGB color. And for convenience, it can be displayed also as an HSL value. But these aren't different. These are all directly related to this. So hue can be thought of as the number of degrees on a color circle. And red is 0. And you can see that over here. So if I add 180, that would be like going around halfway around the circle. So if I do plus 180 to my hue, I'll get this cyan. So I can type plus 180. And my new color is this cyan here. I can also try plus 90. So I can't remember if that goes up or down. Let's see. Okay, it went up 90 degrees. So I was here, I went up 90 degrees, and it gives me this purplish color. Now you don't need to know the degrees of hue. It's kind of useful to know red, but that's about it. What is useful to know is the circular nature of hue. So this is my hue slider here, and when I go to one end, it's basically the same as the exact other end. So 0 and 360 are the same. I'm at 360 here. Over here I'm at 0. So hue tends to wrap around like that. And just one other relationship I'll mention, when we're at our gray levels here, so this is a shade of gray at 153, you'll notice the saturation is 0. And it doesn't even matter what our hue is. We're still going to be gray because saturation isn't there. But beyond that, HSL is just another way of thinking about color. But really the data is stored as RGB. So a common number you'll see when dealing with colors and a lot of other types of data is this 255. And why does that always show up? Well, it kind of comes down to how data is represented at the bit and byte level. So when we have RGB, what we really have is 1 byte for red, 1 byte for green, and 1 byte for blue. Now a byte can hold 8 bits, and that means it can hold the values 0 through 255. And that's the range of a byte. So that's why you always see 255 there. Let me give you an example. So for example, if we had a byte that was filled with zeros, the value is 0. If we had a byte that was filled all with ones, this is actually 255. And I just put in some other random number here, but this would be 86, this number here. So it's kind of like if you had a 3-digit number, it would be 000 to 999. And with a byte, it's kind of a similar thing, but with binary. So our options are 0 to all these ones here, which is really 255. Now, so far I just talked about RGB, but a lot of times you also have this A value, which stands for alpha. And alpha means transparency. So here's an example of an RGB color. And this color is the same in all situations. It's 203, 97, 69. It's just some color I made up. But you can see that alpha is actually changing in each case. And that's allowing us greater transparency to see what's behind it. So full alpha 255 is no transparency. So that's just our normal solid color. When you start decreasing the alpha, you get more and more transparency. And actually, if I made the transparency 0, it would be completely see-through. Now, alpha is stored 0 to 255. In a program like Affinity Designer, it gives you a scale of 0 to 100 here. It doesn't matter too much. It's close enough, but really, it's going to be 8 bits under the hood, just like RGB is. But alpha is a good concept to know about. Not all file formats support it. For example, JPEG doesn't have a transparent component, but PNGs do. So when you have a PNG file, it actually has alpha data that it can apply to the image to give you transparency. Okay, so let's start building up to the tools that we actually want to learn about. And we're going to start with a histogram. Now, I have this RGB image I made here. I'm actually just going to make it all blue to start with. So and I'm going to just stretch this one so it takes the whole image. So our image is entirely blue. And what I'm going to do is I'm going to bring up the histogram here. So I go to Window, Histogram. I switched to Affinity Photo, by the way, but this is a common feature of all programs. And what we want to understand is, what is this histogram telling us? So I have it set to all channels. Let's just look at blue channel for now. Now sometimes you get these exclamation points because it's very computationally expensive for the computer to always calculate all these colors. So if you want to actually have it done correctly, you can click this here, and that'll just get us the actual data we want. So I have this image. It's 3000 by 1000 pixels, and you can see it says RGBA/8. So you know what that means now. That means we have red, green, blue, alpha channels, 8 bits each. So we know that. So it's 3000 by 1000 pixels. That means there's, by my count, 3 million blue pixels. So there's 3 million blue pixels in this image. Well, let's verify that. So if I go to Window, Histogram, so what this is doing is this is going to show us left to right is going to show us our blue value. Okay, so it's going to show us 0 to 255. So if we have any 0 level blues, they're going to be over here. If we have 128 level blues, it's going to spike here. And if we have our maximum blue, we're going to see a big spike here, which we do. Now the y-axis here, the higher this is counting how many we have of that. Okay, so what this spike should say, I haven't even hovered over it yet, but what it should say is all our pixels, which are 3000 times 1000, which is 3 million, it should say 3 million pixels are 255 blue. So let's check it out. 255, there we go. So level 255, the pixel count is 3 million. Now what happens if I make this blue darker? You can see my graph shifted to the left, and again I'll just correct it there. So now what is my color? 159. So now it should say 3 million pixels are 159 blue. Let's see. 157, 58, 59. So that's counting how many pixels we have at that level. So we have one color. It's very simple. Let's add another level of blue. So I have this blue, let me copy it, and I'll make this one darker. So now I have this new image where I have, I don't know, maybe 1/5 of the screen is really dark blue and this other one is lighter blue. And you can see this lighter blue spike is higher. Okay, so if I hover over it, I forgot to normalize it again. So if I hover over it, I guess it's about 225,000, 2.2 million of the blues are in this range, and this darker blue, about 747,000. And let's just do one more. Let's do a thin little shade of bright blue. And you can see this blue here, this leftmost sliver is this part here. Now just to be clear, this isn't going left to right for the spikes here. So let me actually redo this. So the left to right is measuring the level of blueness, and the height is how many it's counted of that shade of blue. Okay, let's go back to our original image now where we have the red, green, and blue. Now these are all maxed out, these values, so it's red 255, green 255, blue 255. So it's going to be a little tricky to see, but what I want to show you here is our histogram, what it looks like now. So I have all channels selected, but they're overlapping on this end. So if I just show you the red, let's just look at the blue channel first. What you can see is we have about 1/3 of the image, exactly 1/3 of the image as blue 255. And then we have a lot of blues that are absolute 0. And that's from these red and green areas here. So that's what this big spike here is saying. We have no blue in these red and green areas here. And because these are evenly spread out, if I go to the red channel, you can see the similar thing. So bunch of reds at 255, and it's counting a lot of reds that are nothing here. So the green and blues are what's causing the spike here. And we can see the same thing for the green channel. Now when things start to get interesting is when we add more colors, and especially colors that are different proportions of red, green, and blue. So let's just draw another square here, and let's just make it something random, something kind of interesting. Let's go like this purple here. So where does this level? Let's add a little bit of green to it so we get something. So if I go to all channels here, what you can see is that this is perfectly matching our values here. So this green spike, it should be at 102. So let's see. Green 102. Yes, the green is 102. The red is 216. Yes, it's 216. And the blue is maxed out here. So it looks like it's maxed 255. That's right there. So that's kind of the signature of this color here. So now what happens if we make things even a little more confusing? So we have this pink here and this yellowish color here. Well, this yellow color is, what is that? 216, 202, 66. So this red, I'm guessing that's it. 216. Yeah, let me normalize it. Red 216. Yes, it's this there. Green 202. It's that there. And blue 66 is this one here. Right. And now for this one here. Now actually I rotated it from the same thing. So this red 216, they both have red 216. So this red spike is counting the reds from both of them because they're both the same value. This 0 here is this green spike, and this blue 255 is this over here. Okay, so finally the moment you've been waiting for. What does a histogram look like for an actual real image? And I have this green forest image here. Now I think you can guess there's going to be a lot of green in this. So let's take a look. Window, histogram. And yes, the first thing you notice is all of this green here. And actually there's a lot of kind of green and red too. The red is kind of behind it, but I can see it going there a little bit. That's going to be a lot of these yellows, I assume. But this is kind of what you would expect for this type of image here. Now when you look at the channels individually, keep in mind that the histogram is only for that color. So this isn't saying red is the most common of green and blue. It's just saying for all the reds, this is the most common red. For all the greens, this is the most common green. For all the blues, well, I guess this is probably the most common blue here. Let's look at another image. So I'm going to predict this is going to be blue dominant. So let's check it out. And yeah, we see the blues are pretty heavy here. We can see the red distribution. Yeah, a lot, very low. Greens, kind of the green and blue are overlapping in some areas, probably this middle area here. Okay, so now let's talk about the concept of channels. And we have this image here. Obviously it's very red, and let's look at the histogram. And we can see we get this ton of red up here, a little bit of green, and very low blues. Now, what if we wanted to view the red channel or the green channel or the blue channel individually? When I say channel, I mean we just wanted to look at the red colors. Well, I'm using Affinity Photo here, and we have this tab for channels. So you can see right now red, green, and blue are turned on. I'm going to turn off green and blue. And we get this image here, and this is just showing us the levels of red. Let me open up the histogram again. What it's doing is it's taking the red and just putting that in the green and blue pixels. So we have a grayscale image, but it's showing us the levels of red. So all these colors here, all these whites are basically corresponding to these spikes in red. So if I drag my cursor around here, I can see the reds are around, 214, 210s, and that's about in this area here. So that's what this is showing us here, this channel. Let's look at the green channel. I suspect if we look at the greens, we're going to see lots of greens in the, say, 80s area. So let's go there. Now this seems to be the biggest area of kind of continuous color, so let's see what that is. Yeah, you can see the greens are very much in the 80s here. So I'm assuming this corresponds to all of this. And let's look at the blues. So yeah, there's very little blues throughout the whole thing. I'm guessing it's all here. So this is 38, 37. Let's color pick this. And the blues are, yes, I see 40s, 42, 31. So that's what these channels are showing us, the individual colors. Now I put them all in a document side by side so you can kind of see. This is the red, the green, and the blue. And this is the composite, all the RGBs together. So this can be a useful way of understanding what the color breakdown is in an image. And interestingly enough, you can see that these are all black and white. This kind of gives you an appreciation for how hard it is actually to convert a color image to black and white. There's more than one way to do it. It's not a trivial problem to reduce millions of colors to really 256 levels of black and white. There's actually different ways of going about it, but we'll talk about that in another video. But these are channels, and I just kind of want to introduce this concept to you a little bit to give you a different way of visualizing how you can see the levels of RGB in an image. Okay, finally, let's now talk about curves. So far, what we've talked about has kind of been what I would call observational. It's been giving us data about our image. Now when we look at curves, we're going to actually talk about how do we modify our image and what are we actually going to be doing here. So again, I'm back in Affinity Photo, and what I'm going to do is I'm going to add an adjustment layer, and I'm going to click curves. Now this data will actually look familiar if you compare it to a histogram. So here we have our histogram, and The ratio of the screen is a little bit different. This is kind of more of a rectangle, but it's essentially telling us the same data. These curves are telling us the distribution of red, green, and blue colors. So I'll close our histogram. Now, unlike our histogram, this is actually a tool where we can modify values. So I'll click on this curve and I'll drag it up. Maybe you've even done this before, drag stuff up and down. But what is actually happening? So let me undo it and make it back to the starting position. So the curve interface is a little bit different than the histogram interface. What the curve interface is doing is it's telling us on the x-axis here, on this bottom part, these are the values that are in our image. So this is kind of the input. And we can think about the left side as like how much is it being adjusted for the output. Now to begin with, we have a perfectly 45-degree angle. So if you take something in the middle here, let's say this curve, well, if it's going up halfway and it's going left halfway, it's basically the same value. But what we can do is we can actually lift it up a little bit. And I'm lifting up all the values, and you can see it's getting lighter. You can think of these values as moving up, hitting the curve, and then going left, all right? So let's look at this kind of more graphically. This is the unchanged curve graph. So you can see if we have some value here that's like 128, it's hitting the curve, and it's just getting mapped halfway to 128 with no change. And that's what this perfect 45-degree line represents. So now what happens is if I move my curve up a bit, now all these lines are actually going to be hitting a higher point. So for example, 128, this line here might actually be lining up with 178. So you can see our image is getting a little bit lighter. If you look at the sand here, you can see a little bit of color here. It's starting to get burned out. But this is basically what happens when you lift a curve like that. You're essentially taking all the values and you're saying map them to something higher. And in this final example, we have a really extreme example. So I've pushed it all the way to the top. And what you can see is basically everything to the right is just being purely maxed out. So all these colors here are just going straight to white. So it's taking all these greens, reds and blues, and they're just going right up here to 255. And even the ones to the left of it, which were darker, are being made lighter too. So I can give you a live example of all that. So I can drag the middle up. And what you can also do is you can add multiple points. And this is Affinity Photo again, but you can do this with lots of other programs. So I could just drag this part down. And you can see these areas are actually going to get darker, but some of these areas are actually going to get lighter too. So this is kind of a common pattern, an S-curve, to kind of adjust your levels. Some people kind of do it this way. I won't go too much into the theory of how to like adjust your levels well. I'll do that in another video, but I just want you to understand what is actually happening when you do this. So we covered a lot of ground for one video, from RGB basics up to histograms and curves and channels. So if you have any questions for further topics on this subject, or if there's anything in this video that required clarification, please leave a comment below and I'll try to follow up with it. As I said, I'm trying to make this video as a prerequisite to the blend mode and adjustment layers video. So there'll definitely be more content on the way about levels and all these kinds of things. As always, thanks for watching, and I'll see you in the next video.